Hello, everyone. So my name is Arnaud Le Hors. I'm part of the Open Technology Group at IBM. So I'm actually in an interesting situation now because I'm giving you a presentation that was not from me, but from my colleague, Jeff Borek, who couldn't actually come and said, hey, Arnaud, you know this topic really well. Why don't you go give it for me? So, you know, I do know the topic very well, but unlike him, I'm more of an interested party in this debate. So I want to know, full disclosure, I am not without an opinion as to the whole thing behind this. So I am biased in some way. I think the presentation tries to strike a fair balance and remain neutral, and I will try to convey that message, but I will also insert my own opinion as we go, so just beware. By the way, is there anybody here from OSI? Because it's kind of interesting. No, but it's interesting because my colleague decided to tell this story, which is kind of like insight as to the process of how OSI went at coming up with the definition of the open source AI definition. Do you guys know about the open source AI definition from OSI? Who doesn't know? Oh, quite a few people. Okay, interesting. So all right, so let's get into it. Dan took some of my time, so I'd better hurry. It's okay because I like him, so. All right, so I'll go quickly. I'm not going to go through every bullet on this slide. What this is really talking about is, how did the OSI came about in the first place? Back in the early days of open source, there was a lot of debate as to what really was open source. And there was actually a debate or a clash between the Free Software Foundation type of people who wanted everything to be accessible and distributed and have this kind of viral effect with copyleft licenses that force people, if you use our code, then your code must become available also. And so open source and OSI actually were created as a reaction to this to say, well, it's fine, you can have it that way, but not everybody wants to go that way. And there are a lot of corporations who want to use open source and decide when they open source certain things and when they're not. So OSI was actually founded to promote this notion, and the term open source was coined as a counterbalance to the free software. So moving along, I think everybody knows that open source has been extremely successful. Now came AI. And initially, AI was very software-oriented, but then we moved into this models business, which is quite different in nature than a program, a software. And this actually has generated a lot of issues that we're still trying to sort out. So at the same time, I think it's fair to say that, it's not completely clear how the industry wants to go. We are in an open source conference, so of course there are a lot of believers that at the end of the day, the open source will win. But I think it's fair to say that even certain companies that started working in the open with a goal to be completely open, have changed course along the way. And today, we see a plethora of models being distributed on Hugging Face, and people assume, well, it's on Hugging Face, so it's open source. But actually, it's not. Because if you look at the licenses associated with those models, you realize that a lot of them fall really short of being permissive licenses that would be expected from an open source software, actually. So OSI actually, who had been in the business of basically coming up with first a definition based on 4 principles of freedom related to the distribution of software, decided and then went into the process of helping the industry, and we're very grateful for that, to identify which licenses out there actually qualified as open source licenses by respecting those freedoms. And they try to do something similar for AI by saying, okay, we're going to come up with a definition of what an open source AI really is. So they actually worked on this for a few years, and they came up with a definition which they posted about, in the fall last year, and they've been trying to promote this around. So this is the story behind how this definition came about, some of the challenges they were facing. So I kind of already touched on this. I think it's fair to say that, the jury is still out. Of course, strong believers, feel like, well, in fact, open source will win in the end anyway, no matter what some people seem to think. And I mean, there are plenty of examples, and people more and more tend to promote that message. I'll go quick. So this is kind of Jeff's point of view. It's a way to say, well, so I suppose everybody is familiar with the Judgement of Solomon. It's the story of these two women who were fighting over a baby, claiming they were the mothers. They went to see King Solomon and asked for judgment. And King Solomon said, okay, I'm going to arbitrate by cutting the baby in half, and you can each have a half. And one mother said, fine. The other said, no, it's okay. I'll give my kid to the other woman so he can live. And Solomon, in his wisdom, said, okay, you will have the second person, right? You will have the baby, realizing that only the real mother would sacrifice her love for the baby to survive. So this really relates to the reason Jeff brought that into this presentation was because he felt like, sometimes you have two different opposite parties and you're trying to find the way in between, and it's not always easy. So some of the challenges that OSI has been facing in trying to tackle this issue of coming up with a definition of open source AI was first the notion of what kind of license would be acceptable for an open source AI system. And there is this notion, there is a lot of discussion around restricted versus permissive licenses. So it's interesting because what we are seeing is there are a lot of licenses. I mean, some have ridiculous restrictions about, I won't sit, well, I can see it. It's like, if you look at the Llama community agreement, which, is from Meta, they have a restriction that say, yeah, you can do whatever you want up to a certain level of usage. Say 700 million users in the previous months, then you can't use it anymore. And that number may be huge, and it may not concern a lot of people, but it's an arbitrary restriction, which makes the license not compatible as an open source license, or at least not permissive. So there were a lot of debates about this, and they really struggled to figure out which way it was, because there are other licenses that have restrictions that are well-intended. So there are some licenses called RAIL, Responsible AI License. And it has restrictions saying, well, you can use my model, but not to do nasty stuff with it. Basically, you can't develop an application that would be, discriminating one race over another, for instance. But it also says you can't use it for military applications. And so those are restrictions that, even though they're well-intended, that makes them license not permissive. And therefore, at least for some people, it fails the test of being an open source license. And this is all in the context of having more and more regulatory bodies around the world. This just refers to one particular aspect related to cybersecurity in the US that happened a few years ago now. But we're seeing that all around the world. I mean, in the EU, we have the AI Act. There are regulations coming up saying, wait a minute, you can't do everything and anything under the sun. This is going to have an impact on our societies. We need to put, some control over those systems. Another aspect is the fact that, as I was saying, models are not source code. They're typically, a bunch of data. And this is like the open weight models. They basically distribute the model parameters. And this is what you actually can use to do your applications, to do inferencing and a bunch of other things. And so the problem is, if you go to Hugging Face, any model you pick, you'll see at the top, typically it says license, and it has the name of a license. If you're lucky, it has Apache or MIT or some actually recognized open source license. Many times it has a whole bunch of different licenses that are completely custom and with weird restrictions that I was saying. But fundamentally, the problem is those are software license, while in fact, models are not only made of software. In a model distribution, you have at least, so you have source code, but you will also, for like the model architecture, but you also have the code, the data in addition, which is the model weights, right? It's a bunch of data. And if you read from a legal point of view, the license for software does not apply to an artifact of type data. So there's a mismatch there, which is why there is this image in the corner. It's comparing apple to oranges. It's like, well, trying to apply a software license to a piece of data just doesn't work. So there are alternatives. So for your data, you should use something like CDLA, which is a well-established license that does apply to data. And now there is actually a new license that was published by the Linux Foundation called OpenMDW, which was actually built for the very specific purpose of applying to model distribution, recognizing that in a model distribution, you typically have some source code, some data, and some documentation. And so the license was built by combining different licenses. I think it was MIT, CDLA, and the CC BY, which is the Creative Commons for documentation. And they put all of this together into one license, which is fairly simple, in the hope that people can start using this and cover all the different artifacts in an appropriate way. So the last piece has to do with what's included in the distribution. They struggle with two different extremes. One is just open source, is basically saying, well, if you have a license that qualifies as an open source license, possibly permissive, there's also the question of what is actually made available through that distribution. And so at the other extreme, there is open science, which really aims for reproducibility. This is a concept that's not specific to IT by any means. It's a concept that's being used in research in all domains, where essentially the concept is if you come up with some results, to be able to let your peers around the world verify your claims or your discovery, you have to provide them with all the information they need to be able to reproduce your experiment to come up with the same result and then validate the results. And so this is the absolute, opposite of the minimum. It's when you provide everything so that people could possibly reproduce. Of course, in the case of models, I mean, even if we were giving everything, you still need beefy hardware to be able to possibly reproduce them. And it's not a given, but at least in principle. So this is something that OSI really struggled over, is this notion, well, where do we draw the line? So there is an alternative approach, which was, and this is where I'm completely biased because I'm behind this initiative. I'm currently co-chair of the Generative AI Commons, which is part of LFAI in data, and I'm co-author of the Model Openness Framework, which basically provides an alternative by defining 3 different classes of model distribution. One is open model, then there's open tooling model, and open science model. And so it's kind of trying to say, look, we're not going to say it's just black and white. We are trying to be pragmatic. Depending on your use case, you don't necessarily need to be able to reproduce the model, but you need certain guarantees. So we do talk about completeness as well as openness. We are adamant about the openness aspect, which has to be permissive license without restriction. On the other end, from the completeness point of view, this is where we differentiate different types of classes of models. So we think, so there is an interesting backstory to this, which is the two are actually related because the MOF existed before OSI embarked in trying to define, come up with a definition. And in fact, they looked at all the components. We identified 16 components, 17 depending on how you count, such as, you know, the model architecture, the model parameters, the model card, the data card, all these different things taken together. And they basically had a survey and say, okay, which one are the important ones that we really want to have? And then they had basically a survey among the people who participated at the time in their effort. And they say, okay, the most popular ones, we draw the line here. This has to be part of the definition. And it's, you know, I think it's a flawed approach. And they have been, I think it's fair to say that it's been challenging. There hasn't been much adoption of the definition to date. But I think the MOF has the advantage of, you know, being more pragmatic and not be so adamant about being an all or nothing. So there's the question moving forward, right? It's like, well, how are we going to move? So OSI defends itself. They do recognize the shortcomings of their definition. I mean, I think they have been having a hard time. You know, they give presentations to a lot of conferences, and they get pummeled by questions all the time. A lot of questions they don't know how to answer, quite frankly, and they keep reverting to saying, well, sorry, but this is just the first version anyway. We invite you to come and help us work on the second version, which will be better. And this at least gets the ball rolling. You know, and so there's, you know, it's not clear exactly what they're going to do next, but we have an alternative. I do want to point out that there are companies like IBM. Again, I'm biased here, but you know, we have a collection of models. We're trying to do the right thing by providing all the pieces you want, you really need for at least the basic use cases. So we qualify as the open model class in the MOF, and they are released under an Apache 2 license. Apache 2 is applicable, suitable for data, for code and documentation. Unfortunately, it falls short of the data aspect. In the Granite models, we don't share the data, but we share exactly the source of the data we have actually used. So you have an exhaustive list of all the data that was used to train the models. But you know, I'm hoping that IBM might actually switch to using this open MDW license that came up. We were participating in the definition of that license, so I think there's a possibility we get there eventually. But so, this is pretty much it. It's, you know, we'll see how this ends up. You know, I don't have a crystal ball. I think it's, like I said, fair to say that, you know, OSI got a bit burnt. In the end, they have all the parties, nobody's happy. And this is where the judgment of Solomon comes in play, right? In the story that Jeff put together, is like, well, what else could they have done, right? To try to find a better way. And he doesn't claim to have the answer, by the way, but what's clear is that what was done is kind of splitting the baby, which means that nobody is happy. And so, I actually have a booth at the LFA in there. It's not properly a booth. It's a table at the very back of the showcase room. And I invite you in an hour. I'll be there. If you want to see a bit more about the MOF and the MOT is actually an online registry we developed, which allows you to evaluate your model distribution or look at certain models that we have actually registered in the system and see how they fare against the model openness framework that the different classes. So that's about it. I think we are out of time anyway, but I'm happy to take a question or take it after, as you want.